Hello everyone, my name is Jani and today I am going to present my portfolio. As a part of Studio 1, construction project formulation and appraisal, we have carried out a feasibility study of a common effluent treatment plant which is situated at Ahmedabad. The capacity of the common effluent treatment plant is 30 million litre per day. The type of project is greenfield. The site area covered by the project is 20,087 square meter. Estimated project cost of the project is 185 crore with 10 years of operation and maintenance period. Type of contract is engineering, procurement and construction. Project funding is given by the central government, state government and industrial association, and current status of the project is under construction. Now let's talk about the objective of the project. Initially, wastewater from the companies was discharged directly into the sewage pipeline, which regularly overflowed because of the lack of the carrying capacity in the region. The effluent was not treated according to the required criteria, resulting in river water pollution. So the project's objective is to transport, treat, and dispose of wastewater generated by the textile and handscreen printing films to stop the water, air, and land pollution caused by the industrial effluents. So now moving further to the pastel analysis, let's talk about the methodology adopted for the pastel analysis. First, we have identified the external macro factors, then we categorized the factors, then we evaluated their effect on the project, and then project is planned. Pastel analysis is basically political, economical, social factors, technological factors, legal factors, and environmental factors. These are all the external factors which can affect the project. So we have identified them, and it is concluded that among these factors, the major factor that created the need for the common effluent treatment plant are legal and environmental factor. Because in worst situation, court authorities may impose ban on industrial activity or endangering the environment if the laws listed in the legal considerations are broken. Next is CPO analysis. CPO analysis stands for context, problem, and option analysis. So first, in problem analysis, we have listed out the problems which are present at the site. Then we have find out the focal problem, find out the cause of the focal problem, and the effect of the focal problem. In our case, the focal problem was disposal of untreated effluent, and the cause of the focal problems was lack of ethics and tendency to discharge effluents directly to the river to save the money, and the lack of fund for the individual treatment plant. So to eliminate the cause of the focal problem, there are various options available, such as common effluent treatment plant or individual effluent treatment plant, or transfer of the effluent treatment to the existing treatment plant by tanker. So we have carried out the option analysis to find out the best situated option for the cause of the focal problem. So at the end of the option analysis, the common effluent treatment plant came out as the best option available for the cause of the focal problem. Because all the industries which are present on the site are small scale industries, and they don't have enough and sufficient funds for establishing the individual effluent treatment plant. And the transfer of the effluent treatment plant by tanker have a risk of malfunctioning due to inethics of the industrialists. So now moving further to the need of the common effluent treatment plant, we have carried out the gap analysis. After carrying out the gap analysis, we find out that the existing common effluent treatment plant have a very less capacity than the discharge of the industries. So it suggests that the new common effluent treatment plant is needed. And apart from this, we have also carried out the characteristics difference between the raw effluent generated and the standards set by the Central Pollution Control Board and State Pollution Control Board. So as we can see in the graph, there is a lots of difference between the standards and the raw effluents. So if we dispose these effluents without treating them, they can cause major pollution in the rivers. And all these data were gathered from the State Pollution Control Board's website. So now, to find out the capacity of the common effluent treatment plant, we have carried out the demand analysis. First, we have find out the demand drivers which affect the quantity of effluent generated. So these four are the demand drivers which we get from the research papers and the industrial experts. So as we can see in this graph, the majority industries are hand screen printing units industries, and we also carried out the regression analysis to predict the discharge. In regression analysis, we have kept the dependent variable as effluent generated and the independent variable as number of industries. So by performing the regression analysis, we find out that after 15 years there is effluent generation of 30 mld, and after 30 years effluent generation is 44 mld. So we can design our common effluent treatment plant for the 45 mld of the ultimate capacity and 30 mld as a design capacity. In regression analysis, we get a p-value of 2.4%, which is less than 5%, which suggests that our regression model is viable. Next analysis is risk analysis. For risk analysis, we have identified the risk, then we have rated the risk. We have rated this risk by the industrial experts and the on-field experts. Then we have decided the risk response to the identified risk. The graph on left shows the number of risks involved in each phase of the construction of the project and the operation and maintenance period of the project. As I said, we have categorized the identified risk in the various categories. So first graph on the right side shows the different categories wise number of risk, and the second graph shows the risk owners of the project. As we can see, the industrial association and municipal corporation are the highest risk owners of the project, which are on the client side. So here is the list of risks which were identified. The category we have divided the risk are the planning category, environmental category, funding category, contractual category, qualitative category, and national calamities category. The right side is a rating scale is given for the metrics we have prepared for the risk analysis. So here is the risk matrix which we prepared. So left side we can see that very high risk category includes risk of availability of finance, revenue risk, improper planning of correlated infrastructure, and solid waste slide. The right side is a matrix of risk which can be opportunity for the project, or say the positive impact on the project. That include the influence of the public NGOs and the media, the sludge disposal, that if we treat the sludge and dry the sludge, this sludge can be used as a fly ash for the cement making and used as a source of revenue for the municipal corporation. And the influence of the politicians on the project is also opportunity for the project. Then as a part of feasibility study, we have also prepared one breakdown structure for the project from the client side. So we have divided this project into main three phases: inception phase, procurement phase, and EPCC and O&M phase. Inception phase involves project proposal, appointing of feasibility consultant, and approvals. The procurement or say appointment phase involves appointment of project management consultant and contractor for the EPCC and O&M. Third, EPCC O&M phase involves engineering or say design phase, procurement or say vendor selection, construction, commissioning, and operation and maintenance phase. The type of contract chosen for this project is EPC contract. As per the client's project perspective, the project is divided into the three stages. The procurement of civil, mechanical, and electrical materials and equipments is in the scope of contractor. Client is not concerned about this equipments and materials procurement. So at the end of all this analysis, these are the conclusions which we get, that from the pestle analysis, the project need to take the implementation context into the account. Threats and opportunities are integrated by pestle analysis by comprehending external environmental factors. From the CPU analysis, in order to assess the situation, problem analysis concentrates on the issue with its causes and effects. Finally, workable alternatives to the issues are located, and the best choice is chosen with the use of matrix. Here, common effluent treatment plant is chosen as the best option for the focal problem of the effluent discharge. Then, the conclusion derived from the demand analysis is the gap analysis. From the gap analysis, it was found out that the qualitative and quantitative difference between the general guidelines and industrial effluents are huge. From the regression analysis, that we find out that the plant should be designed for the 30 mld and ultimate capacity should be kept as a 45 mld. From the risk analysis, we have find out total 50 risks, and among the 50 risks, we have find out that 3 risks are the opportunity or say have a positive impact on the project. From the work breakdown structure, we concluded that to avoid failure of operation of the common effluent treatment plant in the future, the design, construction, and 10 years of O&M period is included in the scope of contractor. And WBS will be key for the project estimation and tender preparation for the contract. Thank you.